Hello guys, in this video we are going to discuss the solution of the problem exit point in a matrix. So let us look at the problem statement. The problem statement says that given a matrix of size n by m with zeros and 1, you enter the matrix at cell 0, 0 in left to right direction. Whenever you encounter a 0, you retain it in the same direction. Else if you encounter a 1, you have to change the direction to the right of the current direction and change that 1 value to 0. You have to find out from which index you will leave the matrix at the end. So let us try to understand the problem statement with the help of an example. So let us take this example. Here the dimension of matrix is 3 by 3 and the matrix which is given to us is this. And as mentioned in the question, the starting index is 0, 0 which is this element. And the current direction is left to right which is this. Now following this current direction, the next element we will obtain is this element which is 0, 1. The position is 0, 1. Now since this element is 1, so the first thing which we are going to do is we are going to change its value to 0. And after changing its value to 0, we have to decide which direction we need to go. So as we know, our current direction is left to right, which is this. And upon encountering 1, we need to change our direction, and the change would be we need to move towards our right. So now if this is the current direction, then the right will be this. So now we have to go down. So because of which the next element which we will encounter is this element. And let me just mention the direction over here. So this was our direction. Now again we have encountered 1, so again we will repeat the same process. So we are going to make it 0, and after making it 0 we need to determine which direction we need to go to. So our current direction is this, which is top to down, and if we want to take a right from this direction, then the next element will be in this direction, which is right to left. So because of which our next element will be this element, and over here our direction is right to left. Now since this element is 0, so we are supposed to maintain our direction, and once we maintain our direction, what we realize is that we will be exiting out of matrix, because of which the position of this element is our answer. So in this particular case, our answer is, or the index which we are going to return is, this is first row and 0th column. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of the problem, let us first discuss the current direction, and if we have to change that current direction, then what will be our next direction. So let's discuss that. So let us say our current direction is left to right. So if this is our current direction, so this is left to right, and we encounter a 1, and since we encounter a 1, we need to change our direction. So the change direction will be this direction, which is top to down. So over here, the change direction will be top to down, or the next direction will be top to down. Similarly, if our current direction is top to down, so in this case, our current direction is top to down. And if we take a right from this direction, then the next direction will be this direction, which is right to left. So let me write down. So our next direction will be right to left. Similarly, let us discuss the other two directions also. So let us say our current direction is right to left. So if our current direction is right to left, which is this direction, so our change direction, or the next direction will be, our next direction will be down to top. Similarly, if our current direction is down to top, so if our current direction is down to top, which is this direction, then the next direction will be left to right. So in this way, we will be able to determine our next direction when our current direction is given to us. And please remember, the next direction remains unchanged if the current element is 0, the current element of matrix is 0, If the current element of matrix is 1, then in that case we will change our direction, and in that case the next direction will be given as we have discussed. Now in order to ease our implementation, what we are going to do is we are going to represent each of these dimension with a number. So let us do that. So let us say we will represent left to right direction by 0. We will represent top to down direction by 1. Similarly, we will represent right to left by 2 and down to top by 3. So in this way, using 0, 1, 2 and 3, we will be able to represent our directions. Now let us see how we are going to solve our problem. So what we are going to do is we will be at some index I comma j. We are going to check whether this I comma j is 1 or 0. So if I comma j is 1, in that particular case, we know we need to change our direction. So let us say our current direction, we are storing it in a variable which is direction. And let's say its value is some value x. So depending upon the value of x, and please note x will be either 0, 1, 2 or 3. So depending upon the values of x, or depending upon the value of direction, we are going to decide what will be our next direction. So over here, the things which we are going to do is, the first thing which we will do is we are going to set mat of I comma j equals to 0, and we are going to decide the next direction, and we will see it in a bit what will be our next direction. But over here, concept wise, we understand that over here we need to change our next direction, and by changing our next direction, essentially what will happen is I and j values will alter, or rather let me write it down like this: I or j value will change. All right. Otherwise, the current element of matrix is 0, in which case what we need to do is we are going to maintain our direction. Even though we are maintaining our direction, over here also our I or jth value will change. And we will keep on iterating on these two conditions till I or j are in the limit of 0 to, so I ranges from 0 to n, and m and j ranges from 0 to m. So till I and j are in this limit, we are going to iterate on this condition. Once it crosses this limit, then we realize that we are exiting out of the matrix, and in that particular case, the ith and jth, or rather the previous ith and jth value will give our answer. So before I discuss the pseudocode for this problem, let us first discuss how are we going to update our next direction. So let us discuss change direction in the cases where we would like to change our direction. So as we know, our current direction is left to right. And please remember, our left to right is something I'm representing by 0. So this 0 simply means I'm going from left to right. So if my current direction is left to right, so if we recall from our this picture, so if the current direction is left to right, then the next direction is top to down, right? This is my next direction, which is top to down, and top to down is something which we are representing by 1, so because of which our next direction will be top to down. So let us update that. So our next direction will be top to down, which is equals to 1. Now I need to change the values of I and j. So if let us say this is my I comma jth index, and I am at this position, the next element I need to take is, so this is my element, and the current direction which we are going at is this, and we know that the next direction will be this. Since the next direction will be this, so the next element, what will be the index of this element? Well, the index of this element is I plus 1 comma j, right? So the j remains unaltered, I becomes I plus 1. That is how we will find out the next element if we are changing the direction in this way. So let us do that. So if my direction equals to 0, then the next direction will be 1, and my ith value will be I equals to I plus 1. And since j remains unaltered, so we are going to leave it as such. Similarly, if my current direction is 1, so 1 simply means our current direction is top to down. Now if current direction is top to down, then the next direction will be right to left, and right to left is something which we are representing by 2. So our next direction will be 2. So let us update that, and let us find out the indexes also. So if this is the element I am at and my current direction is top to down, which is this, then the next element will be at this position. And what will be the index of this position? Well, the index of this position will be I, since we are not altering the row, but we are altering the common, which is j minus 1. So over here, our j will be altered and this becomes j minus 1. Similarly, if my current direction is 2, which is right to left, so this is my current direction, then in that particular case, my next direction will be bottom to top. So let us update that. So our next direction will be bottom to top, which is represented by 3. And if I have to find out the index, so this is where currently I am, and I need to move to the next element. So, and the next element will be the top of this element. So over here, the index will be I minus 1 comma j. So let us update that. I equals to I minus 1 and j remains as it is. Otherwise, the direction is 3, and 3 simply means we are moving from bottom to top. So this is our direction and we need to change our direction. So in case if we want to change our direction, then the next element will be over here. So this is essentially left to right. So over here, the direction will becomes equals to 0. In such cases, the jth element becomes j plus 1, right? So in this way, we will be able to change our direction and we will be able to update our I and jth pointer. Now let us see how we will be able to change our pointer when we are supposed to maintain our direction. So if we are maintaining our direction, so that simply means if my current direction is 0, so 0 simply means we are going from left to right. Since we are going from left to right, then the next element will be the next element, which is j equals to j plus 1. My current direction is top to bottom. So our current direction is top to bottom. So if this is my current element, then the next element will be at which position? I plus 1 comma j. So over here, I becomes I plus 1. Similarly, if my current direction is 2, so 2 simply represents we are going from right to left. So if this is my current direction and if this is my current element, then the next element will be at index I comma j minus 1. So our j will be equals to j minus 1. Otherwise, if my current direction is bottom to top, and if this is my current element, then the next element is at position I minus 1 comma j. So let us do that. I equals to I minus 1. So in this way, we will be able to update our I and jth counter when we have to change our direction or when we have to maintain our direction. So now, having understood this concept, let us see how we have implemented this in Python. So the code looks something like this. So my current direction is left to right, which I am representing by 0. And this is how we are representing our direction. So 0 simply means left to right, 1 means top to down, 2 means right to left, and 3 means down to top. The starting index is 0, 0. That is why I and j are set to 0. And previous of I and previous of j is my answer. Initially, I have set it to 0. Now what I am doing is I am iterating on I and j till I and j are in the boundaries mentioned in the question. If the current element of the matrix is 1, in which case I need to change the direction, and before changing the direction I also have to update it to 0. So I updated it to 0 and then we are changing the direction as we have discussed. Similarly, if my current element of matrix is 0, in which case I don't have to change the direction, but I need to update my I or jth counter. So the updation is something which I have done over here. And towards the end, once I and j exits from this loop, that simply means we have exited out of our matrix, in which case our previous I and j will hold our answer and that will be our answer. So that's about the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.